Hello. In this video, we want to go ahead and graph the quadratic function following the steps from the previous videos. We have f of x equals negative x squared plus 4x minus 4. So to plot this, the first thing we're going to want to do is we're going to want to look at the leading coefficient. The leading coefficient in this case, notice we have x squared, x, and nothing, which is exactly what we want. So we want to look at the number in front of x squared. And in this case, the number in front of x squared is negative 1. But notice that negative 1 is negative, and that tells me that the function opens down. So the function basically is going to look like this. Excellent. The next thing we want to do is we want to find the vertex. And in order to find the vertex, we want to look at negative b over 2a. So we need to write down what is a. A is negative 1, b is 4, and c is negative 4. And then plug in a and b into this formula. This is going to give me negative 4 over 2 times negative 1. Negative 4 in the numerator, 2 times negative 1 is negative 2, so negative 4 divided by negative 2 is positive 2. So we're going to get a positive 2 out of this. Then we want to find f of 2. To find f of 2, we just plug in the 2 into the function, making this negative 2 squared, and then plus 4 times 2 minus 4. Awesome. 2 squared is 4, negative, so that makes that a negative 4. 4 times 2 is 8, and we have a minus 4 at the end. Negative 4 is negative 8, plus 8 is 0. So this tells me that f of 2 equals 0, and the vertex is going to be the coordinate 2, 0. And I'm going to go ahead and plot that. There we go. Excellent. The next thing we want to do is we want to find the axis of symmetry. And the axis of symmetry is going to be x equals the x-coordinate of the vertex, and the x-coordinate of the vertex is here at 2. So x equals 2 is the axis of symmetry. Excellent. And I'm going to go ahead and plot a vertical dotted line. Awesome. The next thing I want to do is I want to find the x and the y intercepts. The first thing I'm going to do is I'm going to find the y-intercept. And to find the y-intercept, I'm just going to find f of 0. Now, f of 0 gives me negative 0 squared plus 4 times 0 minus 4, and simplify. So it tells me that f of 0 equals negative 4, and the coordinate is going to be 0, negative 4. And I'm going to plot that. 0, negative 4 is right there. Notice, though, that if I have a point 2 units to the left of the axis of symmetry, I need a point 2 units to the right of the axis of symmetry as well. And this has also helped me justify the fact that this is a function opening down. Excellent. Now, notice that the next thing we want to do is we want to find the x-intercepts. But in this case, there's actually only going to be a single x-intercept, and here's why. Look at the vertex. Notice that the vertex has a y-coordinate of 0. So that means that this is the only time, or this will be the only place where the y value is 0 for the entire function, so the x-intercept is going to be the coordinate 2, 0. Sorry. There we go. Because in this case, the x-intercept is the vertex itself. Wonderful. The next thing I want to do is I want to find the domain and the range. Oh, nope. The next thing I want to do is I want to go ahead and graph this. So the 6th step is to graph this. And notice that we're opening down, and we don't need any other points. So graphing this would look something like this. Close enough. Fantastic. The seventh step is going to be to find the domain and range. So the domain, negative infinity to infinity, always. That's why we love it. The range, notice that the function starts at negative infinity, and I can use every y value up to that maximum point of the vertex, which is 0. So the range is going to be negative infinity to 0, including 0, excluding the negative infinity, always. Alrighty. Well, I believe that that's it for this particular video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.